So we're working on 4.3, trigonometric functions of angles. So starting with an acute angle and standard position, which we talked about in the previous lesson, we're looking at something like this. There's our coordinate plane, Cartesian plane. Standard position is here. And then we want a point that will make a acute angle. Then from there, we can make a right triangle where R is the length of the hypotenuse. We've got this definition of quadrantal angles, which means any angle in standard position whose terminal side coincides with an axis. So 90 degrees, 180 degrees, 270 degrees. Back to this point, so it's x comma y. That means this side is x. This length is y. You can find r by using Pythagorean theorem with that x and y. So first example, we've got an angle created by a point at 2, 5. And we want to find r and then calculate the values of the 6 trig functions. So r is going to be Pythagorean theorem, r squared equals x squared plus y squared. R squared equals 2 squared plus 5 squared, 4 plus 25, so r equals the square root of 29. So then our values for each trig function, sine, cosine, and tangent. Remember, we've got so, cot, TOA, which tells us which sine function goes to which sides. Sine goes opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So sine of theta is equal to 5 over square root of 29. Cosine of theta is equal to 2 over square root 29. Tangent of theta is 5 over 2. Cosine, or cotangent, no wait, cosecant, there we go, is equal to square root 29 over 5. Secant is equal to square root 29 over 2. And cotangent is equal to 2 over 5. Last thing here, we're to rationalize our denominators. So it's to be 5 square root 29 over 29. 2 square root 29 over 29. This time we're looking at point in quadrant 3. So we're at -4, -7. So our r would be -4 squared plus -7 squared. So we get r equals square root of 65. So sine of theta, that would be the angle that we'd be using here. But we can also just then still use sine, cosine, tangent like we normally would with this angle here. So we've got sine of theta equals -7 over square root 65. Cosine of theta equals -4 over square root 65. Tangent of theta equals -7 over -4, which would be 7/4. This will be negative 7 square root 65 over 65. Negative 4 square root 65 over 65. And then we would have cosecant the square negative square root 65 over 7. Secant square root negative square root 65 over 4. Tangent before, or cotangent would be 4 over 7. So looking at the signs based off quadrants, in quadrant 1, remember, 1 is top right, 2, 3, 4. In quadrant 1, all of them are going to be positive. In quadrant 2, only the sine and cosecant are positive. Quadrant 3, you can see in quadrant 4. So for example 3 then, we know that this cosine of negative 3/5 is going to be in quadrant 3. Because cosine when it's negative is either quadrant 2 or quadrant 3, and then we're told that we're in quadrant 3. So that means then we would have negative 3 and 5, and we're missing our y. So we do 5 squared equals negative 3 squared plus y squared. 25 equals 9 plus y squared. 16 equals y squared. So y equals 4. Well, plus or minus 4, since you take the square root of both sides. And we see since it's going down, we only want the negative 4. So sine of theta is negative 4/5. So now using trig to find multiple values, cosine of 540, if you think about our coterminal angles, 540 degrees minus 360 equals 180 degrees. For our trig function at 90, 180, 270, and this is 0, 360. Excuse me. At 0, the sine is 0. Cosine is equal to 1. For 90 degrees, sine is 1. Cosine is 0. 180, sine of 180 is equal to negative 1. Cosine of 180 is equal to 0. All right, I've got that backwards, sorry. 0, negative 1. And then for 270, sine, negative 1, cosine is 0. So 540 degrees is the same as 180 degrees, same coterminal. So cosine of 180 plus sine of 270 is, we already know, negative 1. Cosine of 180 is negative 1. So negative 1 plus negative 1 equals negative 2. Then for our next one, pi over 2 is going to be 90 degrees. So cotangent of pi over 2. Well, first let's talk about tangent of pi over 2. That's sine over cosine. Tangent sine over cosine. So for pi over 2, which is 90 degrees, that would be 1 over 0, which is undefined. So then for cotangent, that would be 0 over 1, which is equal to 0. So cotangent of pi over 2 is equal to 0. Tangent of negative pi over 2 would be going this direction, so that's going to be down here. That's going to have the same effect as what this one, of what 90 degrees had. Tangent of negative pi over 2 is going to be undefined because it's sine over cosine, so it's negative 1 over 0, and you can't divide by 0. So your answer for number 2 is undefined. Ranges for trig functions. So sine and cosine, remember range is the y values. And if you think of a sine or a cosine function, they go like this, oscillate back and forth, where their top value is 1 and their bottom value is negative 1. So sine of theta is going to have the range of 1 to negative 1. Cosine of theta is also 1 to negative 1. Tangent of theta is infinity or negative infinity to infinity, and that needs to be parentheses. The graph of a tangent function looks like that. Repeating is a bit terrible, but the y values go on forever and ever. So then for cosecant, basically what that means is that it's going to be we can't have what sine was. So cosecant is going to be negative infinity to negative 1. I'm realizing I've got these written backwards up here. Negative 1, negative 1. Inclusive union 1 to infinity. Secant, same thing. It's going to be negative infinity to negative 1. 1 to infinity. Cotangent, negative infinity to infinity. And there they all are written out again for you. So we will, that's the first half. Then there's going to be a second half. I'll make a second video for y'all to do the 4.3, this 0.4 and 4.3.5.